All right, folks, I'm ready to get started. Welcome back, everyone. Welcome back after your spring break. I hope everybody had a decent break. I hope you made the best of it. Spent some time working, spent some time enjoying yourselves, but certainly getting ahead. And hopefully now you're at a point where you are ready to take on this final part of the semester. We've got roughly 6 weeks left. So it's kind of like crunch time for you. It's the time where everything's going to sort of just be piled upon you. Midterms, maybe papers you have to do for classes, projects, etc. And then, of course, finals. So you have a lot coming up. You should be always thinking about that and always have a plan for how you're going to approach it so that you don't wind up in a position where you don't have enough time to do everything. And certainly, as I hope you've come to understand with this class, that you need to spend a good amount of time understanding the concepts that we're covering because they're new, they're foreign to you, they're not based on sort of intuitive ideas that you would just come up with on your own. They've been developed by economists over, several centuries. And so it's something that you need to spend a lot of time exposing yourself to truly understand it and learn it, and either just use it to do well in this class or carry it with you, in your further studies if you are indeed going to go into the business program. So make sure that you are going to allow yourself, given everything you have coming up, enough time to focus on this course and get the stuff down so you can do well in it. There was a question back there? I never posted it? Okay, well, if that's the case, you should have told me. You should have mentioned something on Piazza. I would have posted it. If that's the case, I'll check it out after. Okay, well, you should have let me know, guys. Uh-huh. Yeah, I did send a message about that. I understand. If you read my emails that I send after every class, I do tell you exactly what's going on. And for that day, I had a problem with the recording, so I said that I would be posting the video from the prior class. But if I have not posted the subsequent video, it just means that I slipped my mind and I need to post it, and that's it. Of course, as I mentioned in the last class. That's why we covered the appendix in the whole lecture. Yeah. Are there other questions that you'd like me to address? All right, cool. So we are going to jump into Chapter 11 today. So Chapter 9 dealt with just laying the sort of like the theoretical foundations for the overall approach that economists take to modeling decision making. So we talked about approaching either or decisions, whether you're either going to do something or you're not going to do something. And we looked at how we sort of calculate costs and benefits of a situation to figure out the answer to those questions. And those have to do with looking at overall costs and overall benefits. And if there's a positive economic profit, then something is worth doing. Now, if the question is how much of something we should do, how much a consumer should consume of a certain good versus another, how much a producer should produce within a given market setting that they exist in, how much questions need to be addressed with marginal analysis, looking at the extra benefit of doing something, be it consume something or produce something, versus the extra cost of doing something, or be that consumption or production. And so we use marginal analysis to answer those questions. We then looked at the specific problem of consumers consuming that we have a very specific model for that allows us to gain a lot of insights into the demand side of the market. So we looked at the benefits of consuming versus the costs. The costs are going to be were considered implicitly, meaning that as as you consume something, you're giving up the consumption of something else. And so what the consumer does is compare the extra benefit per dollar spent of one good versus the extra benefit per dollar spent on another good, which we call the marginal utility per dollar spent. And the optimal point of consumption for a consumer is the point at which they're spending all their money on things that at the point that they're consuming give them the same amount of marginal utility, the extra satisfaction they gain from consuming additional units of something per dollar spent. And that is sort of the equilibrium, the state of rest for a consumer. And so we looked at that equilibrium, getting to it a couple of different ways. One in the proper part of the chapter, just to kind of lay out some of the terminology and some of the concepts, which then got us to that equilibrium and gave us an intuitive understanding of what that equilibrium means. And then we went into the appendix, and the appendix introduced a more complicated model of this approach of understanding how consumers choose what they consume, given that there are prices and they're limited by their income. And it got us to the same equilibrium, that same state of rest. So you get the same result from that. And so the same intuition about what consumers decide to choose and where they ultimately wind up consuming. But we did it a little differently in a way that is more complicated, definitely, and is ultimately the way that it is done in in more advanced applications, which is ultimately where all of this is heading. So that's why it's important for you to understand that sort of consumer choice problem as it's presented in the appendix, using the rest of the chapter to kind of help support your understanding of what you learn in the appendix. And it's going to take some time if you didn't follow my lectures, if you didn't follow me, for you to really understand it. And it's not something you can jump into the middle of, and it's not something we're going to cover again. So you need to spend some real time on this if you haven't already. But I hope that you have. I hope you spent your break getting familiar with these things so that you have them down, and now you can move forward to learn the new stuff. So now we're going to turn to the other side of the market, where now we're going to address the choice of producers to produce a certain amount, meaning supply a certain amount. And it's again going to be dependent on using marginal analysis. What is the extra benefit of producing an additional unit? What is the extra cost of producing an additional unit? That's going to get them to their optimal point of production. But that question is not a simple one, because there's a few reasons why. One, there's various costs that we have to consider for a firm. And in order to understand the cost of the firm, we have to understand what firms do. So we have to talk about what they do, which is production. So we have to model like a general production process. And then from that, we're going to gain the insights we need to establish what the general costs are that firms incur in production. And then we are going to use that framework to compare the costs of producing to the benefits of producing, which are the revenues that firms gain by selling things in markets, to figure out how much firms will want to sell in different market settings. And so that's sort of where we're heading. Once we establish the framework of production and costs, we'll start using it to analyze these optimal decisions by firms, which will provide you your basic intuition about how firms can best operate in different market settings. And so we will kind of explore the range of market settings that firms can operate in using this framework, from the most competitive market setting possible, which we call perfect competition, to the least competitive market setting possible, which is a monopoly, which there's only one seller, and then the cases in between, which kind of are hybrids of these sort of extreme cases. So chapter 11 will establish the nature of the costs that firms have to consider when producing. And then once we have that, chapter 12, we will take on, I believe it's perfect competition and monopoly, but it might be, I forget, because I teach different versions of this class at different levels, so I forget which chapters cover what. But I think the next chapter does at least cover perfect competition, the case of perfect competition. I think that might be it, though. I think it is it. I think we cover monopoly in the subsequent chapter, which will then, I believe, start the last part of the course. So we'll cover this chapter, and then, no, I think we cover monopoly as well. Anyway, either way, this is where we're heading, and at some point we're going to cut it off and we're going to take a second exam. And then we will continue on to the more complicated cases, the in-between cases, which involve several large firms dominating a market but not competing very much because even though there's several large ones, there aren't many in the market overall, and that's called an oligopoly. It's like the next best case from a monopoly. And then the other one is called monopolistic competition, which is kind of like the most competitive market setting you could find, which is perfect competition, but also the firms are able to kind of put their own unique stamp on something that they're selling that is very close to the version that their competitors sell. Like McDonald's selling a burger, they call it a Big Mac versus Burger King selling a Whopper. They're selling basically burgers, but they're able to create the idea that their burger is slightly a different type of thing than their competitors' burgers, and so it gives them a little bit more ability to kind of price the good in a way that benefits them. So they get a little bit more profit out of that than in the most competitive setting. So we're going to be sort of studying these various market settings moving forward. It'll take us to the end of the course, and then there's a couple of more chapters towards the end that deal with some ancillary issues. But that's basically where we're heading, and that's why it's important for you to kind of be really kind of in tune with what we're doing now, because it's going to lay a lot of the foundation for your understanding of the stuff that's going to come later. So if you don't really get the stuff now, then you're going to not be able to know everything later unless you go back and learn this stuff first. So it's all kind of connected. It all builds on itself. So I would recommend that you try your best to kind of just like be in this class, have your mind in the content that we're covering from now until the end, and it'll go well for you. The second exam will go well, and so will the final. So that's what you want, and that's what I want for you. So that's the best way to approach it. Obviously, we see there's a lot of people missing here. They obviously are not as invested in the course as you are. So in the end, there will be curves and all this, but again, there aren't no curves in life. Don't depend on curves. You should be challenging yourself. You should be competing against yourself to try to always hit the highest mark possible, because in the end, if you do that, then you become the best person you can be, and then you can get out there and compete against those people that are at that level as well, and then have a fighting chance against them to get something out of this world. So work really hard this semester and subsequent semesters, and things will work out for you one way or another. All right, having talked about all of that, is there anything you need me to address now before I move forward with the material today? All righty. All right, so we're going to talk about what's called the production function. It's just a very general way of establishing like the relationship between inputs and outputs that firms basically generically undertake. Like it can apply to anything. It can apply to like a waiter, a restaurant that has to hire waiters and food, materials to create their food, and cooks in order to produce meals, or like an auto factory that needs like engines and car frames and steel and and rubber for the tires, or already made tires to complete the car. So it can apply to any type of production. We have to be as general as possible about it, and I will be. And then that will take me to the cost. Once I establish the very general nature of production, then that'll allow us to talk about what are the costs that firms face to produce. And we'll get very specific about them. There'll be several different types of costs that we need to consider in order to then be able to understand how firms can best operate in different market settings. And by that, we mean like maximize their profits. And so that is the emphasis that we place on on what we call optimal behavior by firms, that they maximize their profits, because how the valuation of firms is done in markets where you see like a firm is worth this much money or whatever, that is usually going to be a reflection of sort of looking at like all their contracts over a long period of time and saying like how much in profits do they expect to make over a certain period of time, and then that's how much the firms are valued. They're valued as a reflection of like their profits. And so ultimately what we do here is try to sort of mimic this behavior of the firms always trying to maximize how much their profits are going to be, which essentially means that they're maximizing the value of their firms. And so we need all of this to be able to get to that. And so, it's like we live in a complicated world. Markets are complicated. Business is complicated. You have to be complicated in the way you understand it, or you will not understand it in the right way. And therefore, like all of this will be worthless to you. So, you just kind of have to let in the complexity and just kind of give yourself over to it. And again, anything that's complex requires some time to really just get it down. And that's where your part comes in. So make sure that you play your part and not just like try to survive the course. Like actually try to learn some of this stuff. All right, let's talk about going behind the supply curve and talking about the inputs that lead to production and then how that leads us to costs. So again, the first thing we're going to talk about is the production function. So very generally, a firm is an organization that produces goods or services for sale. So we're always going to talk about companies with the name firms. We're always going to regard them as firms. That's how we talk about producers in economics. We refer to them as the firms that produce. So firms, in order to produce goods or services for sale, they must transform inputs into output, right? They have to set up factories. They have to buy machinery. They have to buy, all the tools they need to be able to produce, but they need to pay people as well to put some of these things together. So there's going to be two main categories that we'll consider for inputs. One is going to be labor, the people that work, and then the other one we'll just call capital, which will be a catch-all term for everything else that's used to produce. So the production function is the relationship between the quantity of inputs, or capital and labor, that a firm uses to produce a quantity of output. So that's the most general way that we can describe what a firm does. We can embody that process in what's called the production function. We'll talk again very generally about it here. We'll look at it graphically, but ultimately it is a mathematical relationship. And so that's something that you'll learn about in more advanced courses. All right, let's talk about inputs and outputs. So to understand the concept of a production function, we'll consider an example. We'll consider an example of a farm that we assume produces only one output, wheat, and only uses two inputs, land and labor. So the land is what we'll consider to be the capital, and then labor obviously is just the people. So this particular farm is owned by a couple named George and Martha. They hire workers to do actual physical labor on the farm. We're going to assume that all potential workers are of the same quality, so we're not going to assume that any are more skilled than others. We're not going to assume that that any of them are paid more than others. Everybody's paid the same. George and Martha's farm sits on 10 acres of land, so that's their capital. That's what they have to be able to produce the wheat. They have their land, and it's fixed right now at 10 acres. No more acres are available to them, and they are currently unable to increase or decrease the size of their farm by selling, buying, or leasing acreage. So we're just assuming that right now. So this land that they cannot change the amount of is their fixed input. It's an input whose quantity is fixed for a period of time and cannot be varied. So they've either bought the land and paid for it, or they're renting it. Either way, it is as much land as they have to use. It is their fixed input. So George and Martha are, however, free to decide how many workers to hire. So they have a certain amount of fixed land. They want to produce as much wheat as possible. They can't increase the amount of land they have to produce more wheat. So therefore, to produce more wheat, they hire more people. That's the only way that they can increase the amount of output they produce. And so then labor is their variable input, an input whose quantity the firm can vary at any time. So those are the two inputs that a firm will use, either a fixed input or a variable input. So then, given the fact that there is a fixed input, that puts the firm in a very specific time frame, which we call the short run. So the short run is defined as a time period during which at least one input is fixed. So if there's just one input fixed into production, the firm is, by definition, in the short run. That's how we define the short run in microeconomics, as a time period in which one input into production is fixed, meaning there is a fixed input. In this case, George and Martha are in the short run. They have a fixed amount of acreage to use to be able to produce wheat. In the long run, firms can adjust the quantity of any input. So in the long run, there are no fixed inputs. In the long run, all inputs are variable, and they basically just, like a producer will just like think about how much do I want to produce. George and Martha will think about how much wheat they want to produce. And they'll say, well, what are the best combinations of acreage and people that we can use to produce the most that's going to cost us the least? So that's something that firms can do in the long run when they're able to adjust all their inputs. But in the short run, they're not able to. And therefore, they have a fixed input. And the only way they can increase their output is via changing the variable input. But that does create a limitation for them, because that variable input has to just work with the fixed input. And so that creates issues for the firm as they hire more and more people, which we'll talk about right now. So again, in the long run, there are no fixed inputs. In this section, we will restrict our attention to the short run. In just this section of the chapter, we'll talk about the short run. In the end of the chapter, we'll talk about the long run. So George and Martha know that the quantity of wheat they produce depends on the number of workers they hire. Again, that is their variable input. That's the only way they can increase their output, by hiring more people. Using modern farming techniques, one worker is able to cultivate a 10-acre farm, but they're able to do it slowly. So they can just hire one person, but that one person is then responsible for everything, making all the wheat. And so, takes them a lot of time, and therefore makes sense for George and Martha to hire more people so they can produce more and faster. So with the second worker, the land is divided equally among all the workers. So they divide the land up equally. Now they each have 5 acres. They're able to cultivate the land better, and they're able to produce more each. As additional workers are employed, the 10 acres of land are cultivated more intensely, yielding more bushels of wheat. So the farm recognizes they can make money off selling wheat, so they want to produce as much wheat as possible. So they start hiring more and more people. The people start dividing up the land. They start producing more, but eventually, the land amount becomes a limitation for them. You have more and more people working on the land. They start getting in each other's way. There just isn't enough tools to go around for them to cultivate the land as well. They're still increasing the amount they can produce by hiring additional people, but the additional amounts that are produced by hiring each additional person is not going to be as much as the prior person hired, because again, they are limited by the amount of acreage that they're using to cultivate the land. So we can capture all of these characteristics that, again, result from the firm being in the short run, wanting to produce more, but being limited by the fact that they have a fixed input, which is their capital, their land in this case, with what's called a production function. So the production function for George and Martha's farm, where land is the fixed input and labor is the variable input, is shown in the first 2 columns of the table below. So the production function can be represented as just a table showing us the amount of input and how much output that results in. So here we have quantity of labor, quantity of wheat. 0 workers obviously result in 0 bushels of wheat. Hiring 1 worker will result in 19 bushels of wheat. Hiring a second worker will result in a total amount of 36 bushels of wheat. So therefore we have 17 additional bushels produced by that second person. Third person hired Total amount of bushels produced goes up to 51. The difference that third person makes, though, is 15? So 15 bushels of wheat. So we see that hiring additional people is increasing the amount of wheat being produced overall, but the extra amount that each person is producing is decreasing because of the fact that they are in the short run and they are limited by the amount of capital that they have, in this case, land. So we can plot these numbers on the XY axis, putting quantity on the Y axis, quantity of output on the Y axis and quantity of the input being labor on the X axis. And plotting the points and connecting them will give us what's called the total product curve. The total product curve is the production function in the short run. It shows the quantity of output, that the quantity of output depends on the quantity of the variable input for a given quantity of a fixed input. So again, we're assuming we have a certain amount of land in this case that's fixed, and that is causing us to be able to produce more and more. But we see that it's kind of flattening out the curve as we move from left to right, as we hire more and more people, because again, like, they are limited by the amount of the land that they are using. So that extra amount that folks are able to produce, each additional person is able to produce, is called the marginal product of labor. We can also denote it as MP subscript L. That's just another way of writing marginal product of labor. And that's the additional quantity of output from using one more unit of labor. So again, hiring that first person produced an overall amount of 19 bushels. So their marginal product of labor was 19 bushels. Hiring the second person got total product up to 36, but the marginal product of the second person is equal to 17. Third person, again, overall amount produced was 51, but the marginal product of that third person was 15. So the extra amount of output produced by employing an additional laborer, the marginal product of labor, as we see, is going down as we hire more and more people, which is why the curve is flattening out from left to right. So in general, not necessarily just talking about labor, but all inputs into production, the marginal product of an input is the additional quantity of output that is produced by using one more unit of that input. So marginal product can be of anything. Like, you can think of it as the extra amount of output that you can produce by employing like one additional machine. So that could be the marginal product of your capital, which is your machines that you use to produce. Marginal product can, again, be of anything. But here we're talking specifically, in our example, we're talking specifically about labor being our variable input, and we're looking at the additional amount of output that can be produced given a certain fixed amount of capital as we hire more and more labor. So we're looking at the marginal product of labor. So although the total product curve slopes upward along its entire length, the slope isn't constant. So again, it's starting to flatten out. So the slope of it, the rise over the run as we move from left to right, is starting to become smaller and smaller. That is the marginal product of labor. The marginal product of labor is the slope at any given point on this curve, and it tells us the additional amount of output that can be produced by employing an additional unit of labor. Sometimes we don't have data, though, available for increments of 1 unit. So we don't have data for, like, let's say, adding 1 laborer, how much their marginal product of labor will be, and then, going to the second. Maybe you go from 0 to 10. Maybe you have data in increments of 10. And so when you have that, we use the following equation to calculate the marginal product of labor. We look at the change in the quantity of output produced by 1 additional unit of labor. So it's the change in quantity of output divided by the change in quantity of labor. That's how we can figure out the marginal product of labor. Another way to represent that is our marginal product of labor is equal to the change in our quantity. So this triangle is just a way of representing change in economics. We looked at the same notation in the last chapter, and we talked about the change in overall utility, the marginal utility of an additional unit of something that was consumed. It was the change in utility over the change in quantity. This is the change in quantity over the change in labor. It's just a really simple way of writing the marginal product of labor and how you can calculate it. So if, let's say, the total product starts at 230 and increases to 285 when 10 additional workers are hired, the marginal product of each of those 10 workers is going to be the change in quantity over the change in labor, which is the change in quantity, 285 minus 230 over the change in labor, which is 10. So that's 55 over 10, and we can reduce that down to 5.5 extra units per labor. So the marginal product of labor over this increase of 10 workers is 5.5 units there. So that's, again, the case where you don't have like incremental increases, and you just have maybe like a range of increase of like how much production increased over a range of maybe 10 people that were added. All right. So over here we have our marginal product of labor curve, which essentially plots out the slope at each of these points, basically telling us that the marginal product of labor is diminishing. So in general, there are diminishing returns to an input when an increase in the quantity of that input holding the quantity of other inputs fixed reduces the input's marginal product. So due to the fact that there is a fixed input, that is going to cause the marginal product of our input, in this case labor, to diminish. And therefore, each additional unit will produce a positive amount. Each additional person hired will produce a positive amount, but it won't be as much as the last person hired because, again, they are dividing up the capital. They're limited by how much capital there is overall, and that is creating a limitation for the workers in terms of like how efficient they can be in production. And so that's what it means to have diminishing returns to labor. And this curve just basically plots out that last column that we looked at in the prior slide. So diminishing returns is an other things equal proposition, meaning that we're assuming that we are holding capital fixed, the amount of land in this case fixed. And so that is what leads to the diminishing returns. But if you were to change the amount of capital, the amount of land in this case, then that would completely shift the total product curve, and it would shift the entire marginal product of labor curve as well. So if the amount of capital changes, the total product curve will shift. So over here we've got a total product curve where the farm has 10 acres of land. This is the marginal product of labor curve associated with that total product curve. Let's say that so what happens is, in terms of like our terminology and how we sort of describe these things, when like, let's say George and Martha are at a point where they're like, okay, it's time for us to increase the amount of farmland that we have. So they're like, all right, let's double the amount of farmland. At the point they're able to do that, they're able to adjust both their labor and their capital. So that's a long run situation for them. They're in the long run. So let's assume that George and Martha got into the long run, bought another 20 acres of farm, but as soon as they limit their farm land again, they are once again in a new short run situation. It's different than the one they were on because now they have more of their capital to use, their farmland, but once again they are limited by that amount. And so it does shift their total product curve, putting them into a new short-run situation, which leads to the marginal product of labor at every level of labor to increase because now each additional laborer has more farm to work with. And so they can produce more individually. So like that first laborer was able to produce around 19 units when the farmland was 10 acres. Now when the farmland is 20 acres, that first person that's hired is able to produce roughly, let's say, 29 units. And again, because the laborers are limited by the amount of capital, once again, you're going to see diminishing returns. So you're still going to have that negative marginal product of labor curve, which is also captured by the sort of flattening out of the total product curve. it's not going to be as dramatic as it was when the farm originally only had 10 acres. So so that is what's going to happen, at least graphically, to a total product curve when the amount of capital is increased. The total product curve will shift up, and so will the marginal product of labor curve. So the figure demonstrates the general result that the position of the total product curve of a given input and its respective marginal product curve depends on the quantities of other inputs. All right, so that's production. So now we're going to take what we understand about production in the short run, and we're going to think about what are the various costs that the firm faces, given the circumstances that they're in. We have to consider different costs because the different costs are going to tell us different things about how well a firm is operating at any given time. So we'll talk about the different costs that are most important. Some of them we'll get to today, and some of them we won't. All right, so once more, George and Martha know their production function. They know the relationship between inputs of labor and land and the output of wheat. But if they want to maximize their profits, which again is how firms are valued in terms of how much profit they make, they need to translate this knowledge into information about the relationship between the quantity of output and the costs associated with producing a certain quantity of output. To do this, we need to know how much the firm must pay for its inputs. So we have to establish a price for each of their inputs, a price for their labor and a price for their capital. I screwed up the order there. Anyway, so the first cost they consider is their fixed cost, the cost of their fixed input, which we can denote by just FC, just write the acronym for fixed cost. So it's a cost that does not depend on the quantity of output produced in the short run, meaning, again, George and Martha, they bought a certain amount of land that got them into one short run situation, and they paid for it. And that's it. Like, the amount they paid for that amount of land is their fixed cost. And as they increase the amount of wheat they produce, hire more and more people to produce more wheat, that amount they spent on that land doesn't change because they're in the short run. And so the cost of the fixed input is the fixed cost of producing. In business, fixed cost is often referred to as the overhead cost. So fixed costs can take different forms, but generally it is costs that do not depend on the amount of output being produced. Meaning, as you produce more, that cost doesn't change. So it's the cost of buying your building. It's the cost of your resources that you need to be able to produce that you cannot change. It's your fixed inputs cost. So we're going to assume that George and Martha face either an explicit or an implicit cost of $400 for the use of their land, meaning they either paid $400 for their land, and therefore they're paying some kind of rent. Let's say they're paying rent for their land, like it's not theirs, and they're renting it, so they're paying the $400. The other way of looking at it, that's the explicit way of looking at it. The implicit way of looking at it is that they already own the land, but they could be renting it out. So there's an opportunity cost to the land. The next best alternative for the use of their land, which is to rent it out to somebody else. So they could be making $400. So either way, they are incurring this $400 in costs, either by paying for the land, let's say on a monthly basis for rent, or not being able to collect rent because they're using the land themselves that they own. So depending, you can look at it different ways. Again, when we're talking about costs in this class, we're talking about both explicit and implicit costs. So you have to always kind of look at it. You have to always take these costs into account, regardless of whether they are explicit or implicit. All right, so there's the fixed cost of the fixed input, and of course there's a variable input, so there's going to be a variable cost. We denote that VC, just again an acronym, variable cost, VC. So that's a cost that depends on the quantity of output produced. So the variable cost in the very general example we're tracking here is labor. The firm is hiring more and more people, And as they hire more and more people, they have to pay them more in order to produce more. So as they produce more, their costs go up because they have to pay more and more wages to people. So that is their variable cost. It is the cost of their variable input. So we're going to assume that George and Martha must pay each worker, let's say, $200. All right, so that brings us then to their total costs, or we can just denote it TC, of the quantity of output, and that is the sum of the fixed cost plus the variable cost. That's going to be their total cost, the sum of the fixed cost and the variable cost of producing a given quantity of output. So total cost equals fixed cost plus variable cost, or you can just use the acronyms TC equals FC plus VC. So if the fixed cost is $800 and the variable cost is $1,000, then the total cost is obviously going to be the sum of those two, $1,800. Let's say total cost is $1,600 and variable cost is $300. What's going to be fixed cost? $1,300, right? Just the difference between total cost and variable cost, right? So you can manipulate this expression to figure out the other costs depending on the information you're given. So here we were given total cost and variable cost, and we figured out fixed cost by just subtracting variable cost from total cost. 1,600 minus 300 got us a 1,300 variable cost. If total cost is 2,400 and fixed cost is 800, then variable cost is? That is not correct. It's 1,600, right? Exactly. Total cost is 2,400. We have a fixed cost of 800, so then we have to subtract 800 from our total cost to figure out our variable costs. So that's 2,400 minus 800, which is 1,600. So you should understand the relation between costs and also how to figure out costs given different information that you're given. All right, so the table here shows how total cost is calculated for George and Martha's farm. So we've got, again, so here's a certain quantity of labor. Here's a certain quantity of wheat that's being produced. Here's the variable cost. Here's the fixed cost, and here's the total cost. So with one worker, the variable cost is equal to 200. The fixed cost is $400. It's the amount they pay for their land, and it doesn't change depending on the amount of output being produced. So we see that as we increase the amount of laborers, we're increasing our amount of output, and we see that our fixed cost isn't changing because it doesn't change with the amount of output. So the only thing that's changing is our variable cost, and that's the only thing that's affecting our total costs from changing. So when they're producing 0, they still have a fixed cost of 400, so their total cost is equal to 0 variable cost plus fixed cost of 400, which is equal to $400. When they hire one person, that one person costs them $200 in wages. They still have that fixed cost of 400 that they paid for their farm, so their total cost is equal to 200 plus 400, which is 600. And that relationship continues on down the table. Yeah. The fixed cost, it's the cost of the fixed input. So in this example, it's the amount of land, the farmland they use, and we assume that it costs $400. All right, so we can plot this information as a curve, surprisingly, which we call the total cost curve. It's a curve that shows how total cost depends on the quantity of output. So it's total cost as a function of the amount that's being produced. In this case, the total cost on the y-axis as a function on the x-axis of the amount of wheat in bushels that are being produced. And we see that total costs are increasing as we are increasing the amount of wheat being produced. But it's not increasing at a steady rate. It's increasing at an increasing rate. It's kind of curving upward. We'll talk about why that is in a second. So unlike the total product curve, which gets flatter as employment rises, the total cost curve gets steeper. So remember, the total product curve got flatter because of diminishing returns to labor. Again, diminishing returns to labor was a result of the laborers being limited by the amount of capital they were using, the amount of land. And because of that, each additional person was producing positive amounts, but less than the prior person because you hire more and more people on the same amount of land. They're able to produce more, but not as much as having less people because, again, they start getting in each other's way. There's not enough land to go around for them to produce as efficiently as they want to. So total costs start to increase at an increasing rate due to the fact that there are diminishing returns to labor, due to the fact that there is this limitation that the firm faces. And so as long as a firm has fixed costs and they are in a short-run situation, they will encounter diminishing returns, and that will lead to increasing total costs at an increasing rate, as we see here. And therefore, our total cost curve will always at least have a range of it, a portion of it that will be increasing as output is increasing. So if enough time passes and enough folks are hired to produce more and more, then total costs will start to increase at an increasing rate due to diminishing returns. Now we're going to get to talk about the most important costs, which are the marginal costs and the average costs. So remember, this is all about laying the foundations for being able to do marginal analysis to figure out how much firms should sell in different market settings. Marginal analysis involves comparing marginal benefit to marginal cost. So we can look at total cost, but we really ultimately need to understand marginal cost. How much does that extra unit of wheat cost me to produce? How does that compare to my extra benefit of selling wheat, which is the amount I get from the market, the price people pay me for it? If the extra benefit, the marginal cost, is less than the marginal benefit, I should keep producing and produce more. But if my marginal benefit is less than my marginal cost, I shouldn't produce. So there's going to be a point where the firm is going to stop. So we need to understand marginal cost to be able to analyze that decision. That's what this is about. And then the average cost, once the firm knows how much it should produce, then they have to figure out, well, on average, how much does it cost me to produce at this level? And then that tells them how much their profits can be. It tells them how much their total costs are, and then they compare that to how much their revenues are, how much money they're getting by selling. The price times the quantity is revenue. And then they can figure out how much their profits are, and ultimately that's the whole point, to maximize their profits. So marginal cost and average cost, very key to understanding everything we're going to be doing. So just make sure you understand how we get to marginal cost and average cost and how they work. But I'll be emphasizing what you'll need to know as we move forward, of course. All right, so let's talk about marginal cost. So now we're going to be looking at a different example. We're looking at Selena's gourmet salsas. So Selena produces gourmet salsas. They're bottled salsas. And the table shows how its cost per day depends on the number of cases of salsa it produces per day. So again, she's got a fixed cost. It's $108 is her fixed cost. It doesn't change depending on how much she wants to produce because it's fixed. And then there's a variable cost, of course, and that is attributable to, let's say, labor again. So we'll just call that labor. For her fixed costs, it's probably going to be like, the factory that she works in to make the salsas, the amount of machines, conveyor belts, whatever that she uses to make the salsas. Let's assume it just cost her $108. So again, here we've got our total cost, which is the sum of fixed cost plus variable cost at any given level of output. So at the 5 salsa bottles, fixed cost is 108, variable cost is 300, total cost is 408. At 6, this is cases of salsa, fixed cost once again 108, variable cost is equal to 432. So total cost is the sum of the two, which is equal to 540. So total cost change going from level 5 to level 6, meaning that to produce that 6th case of salsa, her total cost went up from $408 to $540. So the marginal cost, the extra cost of producing that extra case of salsas was $132. In Chapter 9, we define marginal cost as the change in total cost generated by producing one more unit of output. That's essentially what we're looking at here. So that concept, that general concept, is just being applied to a specific situation, but the nature of marginal cost as we introduced it and understood it in Chapter 9 hasn't changed. It's still the extra cost of, in this case, producing one additional unit of output. So the general formula for marginal cost is equal to the change in total cost generated by one additional unit of output, the change in total cost divided by the change in quantity of output. Or we can just call marginal cost MC. Just use the acronym MC, and it equals to the change, again, triangle, change in TC, total cost divided by change in quantity, change in Q. So change in TC over change in Q is our marginal cost. And again, like in the marginal product, where we were able to calculate it based on looking at a range of how output changed when a range of inputs changed, like it was the difference between a certain amount of output over 10 units of labor, and we figured out it was 5.5 extra units per labor produced. So the marginal product over that range was 5.5. We can do the same thing here. If we don't have data on like incremental units, producing additional units and seeing what the marginal cost is, let's say you just have data for producing 5 units and then 10 units, then you can calculate the marginal cost by, again, getting the difference between the total cost at 5 units and 10 units, and then the change in quantity, which is 5, and divide that to get the marginal cost over that range. So if total cost increases from, let's say, 3,800 to 5,300 when 10 additional units are produced, the marginal cost of each of those 10 units is going to equal, again, the change in total cost over the change in quantity. So that's 5,300 minus 3,800 divided by 10, which equals 1,500 divided by 10. If you simplify that to get it for 1 unit on the denominator, it tells us that over this range, each additional unit, the marginal cost of each additional unit is $150. If total cost increases from, let's say, 58,000 to 64,000, when output increases from 3,000 to 3,100 units, the marginal cost of each of those additional units is, again, the difference between total costs, 64,000 minus 58,000, over the difference in the units. I'm sorry, this shouldn't have dollar signs in there. I just made these last night. I wanted to give you a little bit more practice in calculating this stuff. Anyway, this is 3,100 divided by 300, which is 100. So 6,000 divided by 100 equals 600. So the marginal cost of each additional unit, given what happened to total cost when the amount of output was increased by 100 units, is 600. All right, marginal cost is also the slope of our total cost curve. So much like the marginal product of labor was the slope of the total product curve, and we had diminishing returns to that, which causes the total product curve to flatten out. The marginal cost is the slope of our total cost curve, and we see that marginal cost is increasing. So going from 0 to 1 unit, 0 units, we had a fixed cost of 108, variable cost of 0, so total cost was 108. She wanted to produce 1 unit of salsa. So to produce 1 unit of salsa, she incurred a variable cost of $12 and a fixed cost of 108. So fixed cost was variable cost equals 120. The change in total cost with respect to the change in quantity in this case is $12. So the total cost of producing 1 unit went from 108 to 120. So the marginal cost was 12. And then we see that marginal cost is increasing as we are increasing the amount of salsa that she wants to produce. So that goes from $12 to $36, $60, $84, etc. The increase here means that our total cost curve is going to increase at an increasing rate. Again, at any given point, the marginal cost represents the slope of the curve at that point. So at any given point, it tells us at that point, what is the additional cost of producing an additional unit, which is the marginal cost. So again, marginal cost increases due to diminishing returns to labor. So again, you hire more and more people. They're limited by the amount of capital they're using. And so they have diminishing returns to their marginal product. That means that each additional unit of output requires more time to produce. More time to produce means you got to pay your workers more. That means that the additional cost of producing additional units is going to be increasing. So the marginal cost increases due to diminishing returns to labor. So again, this is all very general. Like we assume these characteristics of what we're talking about here, diminishing returns to an input due to having a fixed input. We assume that to be the characteristic of the most general production process. In reality, things are a little bit more complicated, but this gives you just sort of like the benchmark case, like the simplest case that you can use to compare like actual situations against. Like, all things being equal, this is what should be happening. This is what is happening. What is different between what should be happening and what is happening? Then that's where your creativity, your other knowledge comes into play and helps you to sort of figure out how to best work in whatever situation you're in. But you have a starting point, and that's what this is. That's what all of this is. It's meant to just give you the most general insights into the most average type of situation you could find yourself in, which again, then you build upon that knowledge in practice based on whatever happens to you in your careers. All right, so anyway, so the marginal cost curve is going to slope upward. Again, this here's our marginal cost curve. It's basically plotting these numbers here, and it's telling us that, again, the marginal cost, the extra cost of producing additional units is increasing as we are producing more units due to diminishing returns to our labor input. So as output increases, the marginal product of the variable input declines. More of the variable input must be used to produce each additional unit of output, which is what is causing marginal cost to increase. All right, now let's look at the average cost. All right, so average total cost, often simply called just average cost, is total cost divided by the amount of output at any given level of output. So you can write average total cost as ATC. It equals total cost divided by the quantity of output. Another way to write it is TC, total cost divided by Q. Another thing you could get is you can get your total cost from your average total cost at any given level. So your total cost is equal to your average total cost times your quantity. So basically, taking average total cost equal to total cost over quantity and then multiplying both sides by quantity, you can solve for total cost. So you should be able to manipulate numbers, be able to go from average total cost to total cost and back and forth. Average total cost is important because it tells the producer how much the average or typical unit of output costs to produce. And that's important because, again, different producers will produce at different levels, and they're going to figure out how much to produce based on marginal analysis. Once they figure out how much they're producing, they need to figure out, okay, at this level, how much is it costing me on average to produce? And then they can compare that to how much they're making in the market, and they can figure out their profit. So marginal cost. So again, average total cost is it tells the producer on average how much a typical unit of output costs to produce, whereas marginal cost tells the producer how much one more unit of output costs to produce. And marginal cost will be generally increasing. We'll think about the more realistic case in a second, where first it decreases, then it increases, but it will eventually be increasing. And so therefore, each additional unit produced is going to cost more than the last unit. And so therefore, you need those two pieces of information to figure out how much on average everything is costing you to produce at a particular level, and how much it will cost you to produce an additional unit, which will be different from your average. That's your marginal cost. So confusion between these costs is a major source of error in economics, both in the classroom and in real life. And so it's important to kind of just really get this stuff down now. Marginal cost versus average total cost. All right, so let me jump here. All right, so I've been reworking my my lectures to try to make them better, and sometimes I forget to delete stuff. I think the last slide was one I forgot to delete. Anyway, much like total cost is made up of fixed cost plus variable cost, average total cost can be broken down as well into average total cost, average fixed cost plus average variable cost. So average fixed cost, or AFC, is the fixed cost divided by the quantity of output, also known as the fixed cost per unit of output. And in the short run, that number is always going to be going down because there's a certain amount that's being spent on the fixed input, and that is fixed. The firm wants to increase their output. They do. They increase as much as they can. And so you've got a number that's not changing, the fixed cost, divided by a number that is changing, which is quantity. So you have fixed cost divided by the quantity of output. And so as this number gets bigger, your average fixed cost will be decreasing. And so as output is increased, the average fixed cost of production is decreasing. What does this mean overall? Well, it means at a certain level, you have an average cost of producing. So each unit costs you on average a certain amount to produce. The average fixed cost tells you how much of that amount is attributable to your fixed input. And then the other part is the average variable cost, or AVC, and it's variable cost divided by the quantity of output, also known as variable cost per unit of output. So average variable cost is variable cost divided by quantity of output, VC divided by Q. So average fixed cost is fixed cost divided by Q, FC divided by Q. Average variable cost is VC divided by Q. So like I said, the average fixed cost is always going to be decreasing in the short run, but the average variable cost will, Gesundheit, due to diminishing returns, be going up. Because again, diminishing returns means that each additional person is able to produce, that's hired, is able to produce less than the last person hired. And so that means that each additional unit of output is going to cost more to produce than the last unit of output. And so then the average cost of each unit attributable to the amount you're paying your laborers, which is your average variable cost, is going to be going up. Because again, you need more time, more hours of labor to produce more and more units because of diminishing returns to labor. So another thing we can do is figure out our fixed costs by taking our average fixed cost and multiplying it by quantity. So you can look at your average fixed cost, multiply by quantity, and get to your fixed costs. Or you can get your variable cost from your average variable cost, multiplying it by the quantity. So again, you should be able to jump back and forth from total cost to variable to average cost. Remember, total cost is made up of fixed cost plus variable cost. Average total cost is made up of average fixed cost plus average variable cost. And so they're all related, and you can jump between them. We'll do an exercise to kind of emphasize those connections in a bit. So average fixed cost is equal to average total cost minus average variable cost. That's another thing you can use to get your average fixed cost, because average total cost is equal to average variable cost plus average fixed cost. So our average total cost is equal to average fixed cost plus average variable cost. So that means that you can solve for your average fixed cost by subtracting from your average total cost your average variable cost to get to your average fixed cost. Or you can solve for your average variable cost if you have your average total cost and you have your average fixed cost and you want to figure out what your average variable cost is. You can subtract from your average total cost your average fixed cost. and that'll get your average variable cost. So the table uses data from the example in this section for Selena's gourmet salsas to calculate average total cost. So here's our total cost at every level of production of salsa. Here's our average total cost. Again, at any given point, you have a total cost. You divide it by the quantity, and that gets your average total cost. So to produce 1 unit, the average total cost is 120 because it's 120 in total cost divided by 1. Let's go to 7. Total cost is 696 divided by 7 cases gives us our average total cost of 99.43. Over here, we've got our average fixed cost. So her fixed cost is $108. So 108 divided by 1, her average fixed cost for 1 unit is 108. 2 units, 108 divided by 2, which is 54. 3 units, 108 divided by 3, which is 36, and so on and so forth. So again, average fixed cost is always going to be decreasing in the short run because, again, you're just dividing a number that's not changing fixed cost by a number that is changing quantity, and that will always be spreading out your fixed costs. So your average fixed cost will always be decreasing in the short run. And I'm not just pointing these things out for no reason. Like they mean something. There's a reason for them, and it all is going to build to your overall intuition about these things. So just keep it all in mind. I'm not just randomly throwing information out there for you. It's all important. Average variable costs. So 1 unit, the average variable cost is $12. So therefore, average total cost is the sum of our average fixed cost plus our average variable cost. So that's 108 plus 12, which is 120. Another level, let's say at 8 cases, here we've got average fixed cost of $13.50, average variable cost of 96. 96 plus 13.50 is 109.50, which is our average total cost. All right. Let's just call it a day. Let's call it a day. We'll pick this up next time just so you can get some practice at the beginning of next class. All right, that's pretty much it. So I'll see you guys on Thursday. Have a good couple of days. Work hard.